Okay, this video is going to talk a lot about naming angles. So it's going to show pictures of lines intersecting, and then there's certain special pairs of angles that are worth naming because they have special properties. So we'll just go through it. Let me turn the page. First of all, we're going to talk about supplementary and vertical angles. First thing, supplementary angles. We should know this from previous videos. Supplementary angles are angles that are next to each other, and they add to 180. Supplementary, they add to 180, and they are next to each other on a line. Okay, so angle 1 and 2 are supplementary. That means they would add up. Now, similarly, any of these two angles that are next to each other are supplementary. So angle 2 and angle 3 are supplementary, or angle 3 and angle 4 are supplementary, or even angle 1 and angle 4. Any two angles that are next to each other are supplementary. Okay, so we would say 1 and 2 are supplementary, 2 and 3 are supplementary, 3 and 4 are supplementary, and 1 and 4 are supplementary. All of those pairs of angles would add up to 180. Okay, now vertical angles. Vertical angles are angles that are across from each other when you have two lines intersecting. Okay, and a thing about vertical angles is that they are equal measure. So I'll explain as we look at the picture. Let me erase that. Equal measure. So the angles that are across from each other when you have two lines intersecting, they're equal to each other. So for example, if this angle is 25 degrees, this angle is 25 degrees. Okay? Similarly, this angle here is a vertical angle with this angle here. And so if this one is 155 degrees, then this one is 155 degrees. Those are vertical angles. So let's look at this problem. It's a really ugly picture, but still it's just asking what are the supplementary angles. The supplementary angles are the ones that are next to each other. So actually there's a lot. There's many choices. You can say 1 and 2 are supplementary. They will add up to 180. 2 and 3. 3 and 4, 1 and 4, and also looking at the next intersection over here, you can say 6 and 7 are supplementary, 7 and 8, 8 and 5, 5 and 6. So there are many, many choices for supplementary angles or angles that add up to 180, or they're next to each other. Now let's ask about vertical angles. Again, there's many, many choices. Vertical angles are, if you remember, they're opposite one another, like this. So we can say 1 and 3 are vertical angles, 2 and 4 are vertical angles, 6 and 8 are vertical angles, or 5 and 7. Many choices for angles that are opposite each other. And as you remember, vertical angles, let's write this, they have equal measure. Whatever the measurement for angle 1 is going to be the same measurement for angle 3, and so on. Supplementary angles, if you remember, they add up to 180. Okay. Now we have some more vocabulary words. We have corresponding angles, alternate interior angles, and alternate exterior angles. Now I know this looks crazy with a lot of drawings, but basically, whenever you have two lines running the same direction, and then a line that crosses through them, we have this relationship, or these numbers, or these names. So let's go through one by one. Corresponding angles. I want you to think of each intersection as like a clock, okay? Each intersection, imagine it looks like a clock. So corresponding angles are the angles that are in the same position on the clock. So look, top left here matches with top left here. Or top right here matches with top right here. Or bottom left matches with the bottom left. These purple angles, in this case, are corresponding angles. And we have this one, bottom right, matches with the bottom right. So in this case, sometimes the two lines can be running up and down, and you have a line here that's crossing them. So again, think of each intersection like a clock, and you go to the same spot on the clock. So top left matches with top left, and so on. Okay, now let's look at the alternate interior angles. So again, we've got two lines that are running the same direction, and then a line that cuts through them. Now the interior, think of like the interior of a car. So this word interior means the space inside the lines. And the word alternate means go to the left of the line that cuts them, and then go to the right of the line that cuts them. And similarly, you could go to the left here, and then the right here. Those are the alternate interior angles. So let's look, even if the lines are running the same direction up and down, and then you have a line that crosses them, we've got the interior here, and then we want to alternate on the interior. So this one will go on the top of the line, this one on the bottom. Okay, let's look at alternate exterior. So again, we've got the two lines running the same direction, and then the line that cuts them. And the exterior is the outside, like the exterior of a car. Now we have the exterior of the two lines that are running the same direction. And now we want the alternate. So we're going to go on one side of the line that cuts them, and then the other side of the line that cuts them. And similarly, you could go on this side or this side. Those are the alternate interior angles. Let's look at the other example. When the lines are running up and down, and a line that cuts them, we'll look at the exterior. So the outside of the lines that are running the same direction. And then we'll look at the alternate. So this one is on top of the line that cuts them, this one is on the bottom of the line that cuts them, and so on. Okay, we'll look at this last question. First, it asks for alternate exterior angles. So if you remember, when you have two lines running the same direction and a line that cuts them, the exterior is the outside of the two lines running the same direction. And when we alternate, means we go one on top, one on the bottom of the line that cuts them. So we could have 5 going with 4, or similarly, you could have 1 going with 8. Okay, let's look at alternate interior. So again, we've got the two lines, we've got something that cuts them. The interior is the inside. So in this case, we can take the alternate, so 1 on the top, 1 on the bottom. That would be, in this case, angle 6 and angle 3. Or you could say angle 2 and angle 7. Okay, lastly, we're talking about the corresponding angles. Okay, so we have the two lines, the line that cuts them, and corresponding, it's like a clock. So imagine these two intersection points are like a clock, and we just pick the same spot on the clock, top left, top left. So I could say 5 goes with 7, or if I did bottom left, 1 goes with 3, or 6 goes with 8, that's top right, or 2 goes with 4, that's bottom right, bottom right.